Happy Friday, kings and queens. It's finally time for the weekend. But before we get there, we do have one more lesson that we're going to jump into. We're going to jump into Math 7 Unit 1, Lesson 5b. Today is Friday, October 2nd, 2020, and we are working on page 11 of your Math 7 Spiral Notebook. So let's make sure that in your notebooks on page 11 that you're labeling it as such and that you're dating it Friday, October 2nd, 2020. Our classroom norms are that your camera should be on at this point, your mics are muted, of course, unless you're speaking, and that you are ready to learn and chat. Today, you only need your Math 7 Spiral Notebook and your pencil. Once again, for today's lesson, there is no student companion, so you just need to write down the answers or solve problems in your notebook. So today we are on day 2 of comparing relationships. Now we're going to be comparing them with equations. But we're still talking about whether things are proportional or non-proportional. So for today, our standards are going to be 7.rp.1a and 7.rp.2a. Our objectives are students will compare and contrast equations that do and do not represent proportional relationships. We're also going to generalize that an equation equivalent to the form y equals kx can represent a proportional relationship. And then lastly, we're also going to use a table to determine whether a given equation represents a proportional relationship and justify in writing the decision. Our mathematical practices for today are going to be MP6 and MP7, which are attend to precision and look for and make use of structure. Again, we want to make sure that we're ready to take notes and work collaboratively in our virtual classroom. So let's pause here briefly so that you can finish copying down the standard and objectives into your notes. So now let's move to our engagement activity. So our engagement activity is entitled Patterns with Rectangles. So you have 3 rectangles placed here in our grid. And I want to know, what do you notice and what do you wonder? So what do you notice looking at this image and what do you wonder? So do you see a pattern at all? And what predictions can you make about future rectangles in the set if your pattern continues? So let's pause here, and in the chat, I want to know, do you see a pattern? What do you notice? And then what do you wonder? So hopefully when you notice the pattern, you notice that the width, so how wide each one of our rectangles were, that the width increases by 3 each time. It increased by 3 units each time. And hopefully you notice that the height also increased by 1 each time. Some things that you might be wondering is, how much does the area increase? Or how much does the perimeter increase? Or even which rectangle will have a width of 10. So those are just some things that you might have wondered, but you definitely should have noticed the pattern of the width increasing by 3 each time and the height increasing by 1. So moving right along to comparing relationships with equations, we're going to develop methods for deciding if an equation is proportional. Remember, yesterday we talked about if a table is proportional, we can figure that out by dividing the second column by the first column. But now we want to know, how can we determine that with an equation? So today, our goal is simply, can I decide if a relationship represented by an equation is proportional or not? So that is our goal for today. So we've talked about converting meters and centimeters and millimeters. So in this next activity, you'll be working with some more unit conversions. So we're going to begin with about 5 minutes of quiet work time and be ready to share with your class. If you need a calculator at this time, that also might be important. So we're going to jump into more conversions at this time, which we are going to get more and more comfortable with. So let's look at this table of temperature conversions. It says which equation represents a proportional relationship. So if you notice, I'm given two equations and I'm going to have to complete the table. So hopefully you notice that instantly all I need to do is substitute in my values for the first part of the table into each equation for the variable. So for instance, let's look at the first table. This first equation, even though it looks a little difficult, it's not. It's just the equation for Fahrenheit and Celsius. So F equals 9/5 C plus 32. So wherever I see a C in my first equation, I'm going to plug in the value that is given to us in the table. Well, the first value that's given to us is 20. So I'm going to put 9/5 times 20 plus 32 and simplify. So in order to solve that, I'm just going to do 9/5 or 9 times 20. Then I'm going to divide that number by 5. And then I'm going to add 32. So once again, to do that, if you want to help put this in your calculator, remember multiplying fractions, you just multiply straight across. So I'm going to do 9 times 20, which gives you 180. Then I'm going to take that number and divide it by 5, and that gives me 36. And then the last part of the equation tells me to add 32. So when I add 32 to that, I get 68. So the first column or the first row in my first table for 20 degrees in the Celsius column, it's going to be 68 degrees Fahrenheit, which I obviously got right. So let's take some time. We're going to pause the video here, and then in your notes, let's complete the rest of this table. What's going to happen when I substitute in 4 for C, and what's going to happen when I substitute in 175 for C. So now that you had some time to figure this out, for the second row, you should have had 39.2, and hopefully you're using your calculator for that. And then for the last row for 175, you should have had 347. Now, let's look at the second table. We're going to do the same thing. This equation gives me C equals 2.54N. So all I need to do is multiply wherever I see the variable N by one of these values in the first table. So for instance, the first row gives me 10. So I'm going to do 2.54 times 10. And when I do that, I should get 25.4. Perfect. So all I'm going to do now is we're going to take another minute to figure out the rest of these values. So I'm going to substitute in 8. I'm going to do 2.54 times 8, and then 2.54 times 3.5. So hopefully you were able to get those calculations. So when you substitute in 8, you should get 20.32. And then for 3.5, you could have put 3.5 in your calculators. You should have gotten 8.89 or 8 and 89 hundredths. So 8.89 should have been your value for the last one. So we need to answer the question, which equation represents a proportional relationship? Now, obviously, we need to determine some things here because the last time that we did this, we divided our numbers by we divided the second column by the first column. So I can use that same tactic to do what we did yesterday. So let's take 30 seconds and let's realize which one of these are proportional and which one is not proportional. So again, we're going to take the numbers that we've already figured out from the second column. Let's start with table one. And then we're going to take the second column and divide it by the first column. So for instance, let's do 68 divided by 20, 39.2 divided by 4, and 347 by 175. So once you figure those out in the chat, let's take 1 minute and determine if this is proportional or not proportional. Now that you've done your calculations, hopefully you realize that when you did this division, the quotient of all of these are different. So this, in fact, is not proportional. Now, let's look at our second table. We're going to do 25.4 divided by 10. Our second row, we're going to do 20.32 divided by 8, and then 8.89 divided by 3.5. So let's take the division or the quotient of all three of those rows, and then let's figure out if this is proportional. Now, hopefully, after your calculations, you realize that this one is in fact proportional because when I divide, I get the same number of 2.54 for each one. So, because that constant of proportionality or the unit rate is the same, it is in fact proportional. So, overall, let's remember the temperature conversion equation, which was in our first table, does not represent a proportional relationship because the number of degrees Fahrenheit per degree Celsius is not the same. However, in the second table, the length conversion equation, C equals 2.54 N, does determine a proportional relationship because the number of centimeters per inch is the same. Now, let's keep moving. We want to talk about what do you notice about the forms of each relationship? So let's talk about this. Somebody go ahead, a few of you go ahead and unmute yourselves and talk about what do you notice about the way both of these equations are formed. So thank you for everybody that shared. One thing that I definitely wanted to point out is that there are a lot of things to talk about these two equations, but specifically, I wanted you guys to highlight the proportional relationship, the one that represents a proportion, was the second equation, which was C equals 2.54N. That equation is still of the form y equals kx. Remember, we can change out the variables, but it has 2.54, which is your constant of proportionality multiplied by a variable. If we look at the first equation, this is not of the form y equals kx because we're adding a number 32. So only the proportional relationships are going to be of the form y equals kx. So that'll help us in the future determine whether something is or is not a proportional relationship. Now, let's keep moving and talk about the total edge, length, and surface area. So the first thing that we want to do is complete the table to determine if the equation represents a proportional relationship. So let's start with the first table. We're given the equation E equals 12S, and this is the surface area of a cube. So in your notes, let's go ahead and write down this table, and then I also want you to complete the third column. Okay, so we're going to take about 1 minute and 30 seconds to copy down this first table, E equals 12S, the surface area of a cube, and then we're going to figure out the third column. Once again, we're going to take the total edge length, which is my second column, and divide it by the side length, which is the first column. So for instance, I'm going to do 36 divided by 3, and that'll be my answer for the first table. So let's do that for all of them, and then we'll come back together. So now I want you guys to go ahead and put into the chat, tell me whether or not this first table is proportional or not proportional. Perfect. I'll give you the exact answer in just a second. Now, let's go to our second table. I have A equals 6s squared, and this is the equation for the total edge length of a cube. So let's go ahead and copy down this table, and we want to fill out the third column. So we're going to do the surface area, again, which is our second column, divided by our first column. So for the first one, we're going to do 54 divided by 3. When we get down to the third row where we see fractions, don't get overwhelmed about how to put that in your calculator. 541 and a half, you can just put 541.5 divided by 9.5. And then the last one that has variables, just do that to the best of your ability. And then once you are complete this table, let me know in the chat once again, is number 2 proportional or not proportional? Okay. So now that you guys have given your answers in the chat and said whether or not you agree or disagree, let's go to the answer key. So here are my answers. For the first table, all of my calculations came to 12, which means that 12 is my constant of proportionality and my unit rate. So the first table is in fact a proportion or a proportional relationship because all of the quotients or the answers in my table came out to the same number. Now, when I look at the second table, I get a whole bunch of different numbers. None of these are the same, none of these are consistent. Therefore, this is not a proportional relationship. Okay? So hopefully that makes more sense. So, once again, let's just reiterate how we can determine if an equation is proportional. If I look at the top where it says these are proportional, we have y equals 4x. This is in the form y equals kx, k being 4. So that means that 4 is my constant of proportionality when I do the division, and that represents a proportional relationship. When I look at this bottom one where it says these aren't proportional, I have y equals 4 plus x. That's not of the same form like my first one. And then if I look at the third column in this table, none of those quotients are consistent. So that also tells me these are not proportional. So for instance, these two equations are proportional. In the first table, when I do the division, 8 divided by 2, 12 divided by 3, 16 divided by 4, 20 divided by 5, the quotient is 4. They're all consistent, they're all the same. These are proportional relationships. Now, when I do the second table, and I do 1/2 divided by 2, 3/4 divided by 3, 1 divided by 4, and so forth, I get 1/4. These are all proportional. They're still of the form y equals kx. So we've been doing some work around how to determine this from a table. We know that these are proportional. So let's take some time, and I just want somebody to share out. We don't need to pause the video here, but I'm already telling you that all 4 of these equations are proportional. Y equals 4x, y equals x over 4, y equals 5.2x, and w equals 205n. What do you notice about these equations? So at this time, let's have about 1 or 2 students go ahead and share out what their thoughts are. So, in your conclusions, I'm hoping that you guys realize that all of these, even though the variables may not be the same, the they're still in the form of y equals kx. For instance, in the first one, y equals 4x, k would be 4. In the last one, w equals 205n, even though we're using the variables w and n, it's still similar to y equals kx. K would just be 205. You might be asking, well, y equals x over 4 isn't similar, but if I move my fraction to the front, It's the same thing as y equals 1/4 x, or just x over 4. So if you notice, all of the constant of proportionalities are here. So 4 or 1 over 4 or 5.2 or 205 are all unit rates or constants of proportionality, which tell us that these are going to be proportional relationships. Now, if I look at these two equations, these are not proportional because they're not in the form of y equals kx. The first one has 4 plus x. That's not of the form y equals kx. And the second one has the variable x in the denominator. And if I wanted to check this against the table, if I look at that third column for each table, all of these have different values. So none of these are consistent, meaning that they are not constants of proportionality and not proportional. So just to give a further example, when I look at these equations, all of these are not proportional. Hopefully you also again realize that none of these are in the form y equals kx like our previous equations. So once again, here is a word wall. We're now adding different things about tables for proportional and non-proportional relationships. We've also know that we're looking for things of the form y equals kx or kx equals y, the same thing. So these are just things that we want to be able to keep in mind. So let's talk. So let's just kind of synthesize what we've done in our lesson. So proportional relationships are characterized by equations written in what form? And then how can you use a table to determine proportionality from an equation? So let's just have two students share out their answer to the first one and then one sharing out their answer to the second one. We'll pause here and then reconvene. Great. So remember, proportional relationships, when we're looking at equations, we want them to be of the form y equals kx. We keep saying that. And then for our second question, remember to determine it from a table, we just want to take our second column and divide it by our first column to find a consistent constant of proportionality or unit rate that's the same. If it's the same, we know that it's proportional. If it's not the same, it's not proportional. All right, so let's do our evaluation activity, and we're going to do this together for the sake of time. So it says decide whether or not each equation represents a proportional relationship and justify your reasoning. So all we're going to do is look at each equation, determine if it's of the form y equals kx, and then we're going to say if this is proportional or not proportional. So looking at this first equation, 120 minus x equals L, your video should be on. Give me a thumbs up or a thumbs down whether or not this should be proportional. Thumbs up, yes, it's proportional. Thumbs down, it's not proportional. So for number one, it would be a thumbs down. 120 minus x equals L is not of the form y equals kx. Let's look at B. 1.08 p equals t. You should be giving me a thumbs up. This is of the form y equals kx. It could be t equals 1.08 p, or even if we write it backwards, this is of the form y equals kx. If I look at letter choice C, x equals m over 4, this one could be a little tricky, but this one is thumbs up. This is a proportional relationship. And then last but not least, everybody give me a thumbs up or a thumbs down. V equals 12s squared should be a thumbs down. That is not proportional. So let's go back to our goals. Remember, we wanted to be able to decide if a relationship represented by an equation is proportional or not. And we just extended our learning from yesterday. So again, today is Friday. I'm very glad that it's the weekend, and I'm sure you are as well. So we've already recapped our lesson for today. Remember, you guys will not see us again until Monday for our live class session, which is important. However, you do have an independent assignment today on Mobius Math. All of the directions are going to be posted in Google Classroom. And if you can't get into Mobius Math, there will be an alternative for you to submit your assignment. And then, of course, we want to make sure that you guys are safe and keeping your distance this week because we are still in a pandemic and we want to be able to get back together as soon as possible. Remember, the progress report window closes on Monday, so you want to make sure that you're submitting all of your assignments because progress report grades will be available next week. So let's make sure that we're keeping up on all of our assignments. If you have any questions, you may email myself or Mr. Spencer. Have a great weekend, and we'll see you all on Monday.